Hello everyone, myself Roshni of registration number 18BEC0369. Now I am going to present my COA Digital Assignment 2 Automatic Specific Floating Point Unit Generation. First question is to explain how the selected paper is related to COA syllabus. First I would like to explain about the journal that I chose. Basically, high-performance floating point units are large and complex. They are also costly and power-consuming, time-consuming. The main aim of the selected journal is to reduce reductant resources and save area and power during floating point unit operations. A methodology is proposed for the automatic generation of FPUs at the instruction level with integrated resource sharing to minimize the area of FPU. The experimental setup of FPU generation is also described. So here we deal with various instructions during operations of FPU, which we have already discussed during module 2, processing unit data path under ALU operations. Based on this, we can say that the selected research paper is related to syllabus. The second question is to draw the existing architecture discussed in the paper, and this is the block diagram of the existing architecture. For drawing the block diagram, I use the tool draw.io. This is the tool that I use to draw the diagram. We can easily choose the symbols and create their duplicates. And also connect them easily. We can also add colors to the whole in an easier way. So in this way, I completed drawing the whole block diagram. So here the blue block diagram represents the data path, and the black represents the data path 2, and the dotted lines represents the connection to both the ports. And the third question is to draw the tabulated results. So the results are based on area and time for both non-resource sharing and resource sharing, and the graph related are also drawn. And this is the graph related to time and application for both the data paths. And then the fourth question is to draw the proposed architecture in this paper. So this blue represents the data path 1 and black represents the data path 2 and the whole mentioned data path. We can observe that the existing architecture occupies more area than the proposed architecture. And the fifth question is to draw the transistor level internal diagram. And this is the transistor level, the transistors connected to logical gates, and then finally to a NOT gate to bit 1, and an OR gate, the whole thing is added bit 0. And the sixth question is to compare the proposed architecture with existing architecture. Proposed architecture represents the merged data path, illustrated how the two data paths could be merged. Existing architecture consists of two data paths, which represents a simplified version of the data path for the fractional part of floating point addition. Area occupied is more in the existing architecture compared with the proposed. Similarly, the power consumption is very high in the existing compared to the proposed. Lower level detail is not required in the existing architecture. Due to the complex architectures, lower level detail is necessary to ensure correct operation in proposed architecture. Most of the components have fixed alignments in the existing one. The majority of components have flexible alignments with a few fixed aligned components. So the ones which are fixed cannot be changed, whereas the components that have flexible alignments can be changed as per requirement. And then the advantages of the proposed design over the existing design. FPUs for a simple scalar based processor were generated targeting various applications. So here we discuss a few applications. FPUs were generated for different media applications compared to typical general purpose FPUs. Of all the instructions, the arithmetic and conversion instructions would benefit most from instruction matching as other instructions do not require complex hardware. The floating point architecture was designed to be IEEE 754 compliant. Now we will discuss about the merits and demerits of proposed and existing techniques or hardware. Firstly, coming to proposed technique. The merits are, as we discussed before, the area is very much saved. In floating point architectures, the majority of components have flexible alignments with a few fixed alignment components. Methods for bit alignments is performed by analyzing the compatibility graph. Area savings over a fully featured. Clock period increased in some cases by up to 9.5% due to resource sharing. FPU without resource sharing of 26 to 80% without resource sharing and 33 to 87 is with resource sharing were obtained. Demerits. In few cases, merging results in larger area. We can see in this block diagram the both G1 and G2 parts. When merging the both G1 and G2 parts along with the logic gates, 2 marks are also included. So here the area is increased. Complex architecture associated with floating point makes use of extra lower level details to ensure correct operation. Non-standard formats are less desirable because in general software is developed and verified on IEEE 754 compliant machines. And in existing techniques, merits. It involves simple process with very basic instructions involved, no complex processor performed. Whereas in the proposed technique, most of the techniques are complex, most of the processes are complex and they are also difficult to understand, whereas in the existing technique, it is very easy to understand. Demerits are includes a large monolithic hardware block with considerable number of unused instructions. Most of the instructions here become unused. And the existing one is also time consuming. It is also error prone. And then coming to the applications of proposed design. These floating point operations are crucial for many scientific applications such as processing experimental data, mathematical computations and physical simulations, as well as multimedia applications such as audio, video and graphics processing. Following the application specific instruction set processor philosophy, the operation supported by the FPU can be reduced to the minimum need to execute the desired applications. To test the methodology, FPUs for a simple scalar based processor were generated targeting various applications. The process is based on simple scalar PISA instruction set, which includes the following FP instructions: simple and double precision FP arithmetic instructions that involves addition, subtraction, multiplication, divide and square root, conversion instruction between integer, single and double precision formats, data movement or manipulation instructions like move, absolute, negate, branch decision instructions. These are the processor which includes the following FP instructions. And then finally the flow chart proposed in the design. So here is the step-by-step process in merging of two data paths. Let us consider data path G1 in which A1 and A2 are first multiplied and the result as A4, and then it is added with the A3 and the final result is A5. And then coming to data part G2, B1 and B2 is added, result as B4, and then it is subtracted with B3 and the result is B5. So in order to merge both the data parts, we follow the methods. First is hardware and interconnect mapping. A1 is connected to B1, A2 to B2, A3 to B3. Similarly, A3 to B3 again, and then B4 to A5, A5 to B5. So these are the hardware and interconnect mapping. And then we check the compatibility of the graphs and maximum weight solution. So the compatibility between A2 and B2, A1 and B1, everything is checked and the weight is calculated. So this is GC, compatibility graph. And then based on the compatibility graph, data path is merged. This is G bar. Finally, plus or minus, we take a block as plus or minus and then we included a mux. Thank you. I would like to show the DA2 reference. This is a journal paper that helped me to solve the whole DA2 automatic application specific floating point unit generation. the block diagram, instruction methodology. This is the methodology involved. And all the stimulated results. Thank you.